Hello class, welcome to Digital Electronics class. Hello class, so today we are going to read Serial In, Serial Out Shift Register, or in shortcut you can say SISO Shift Register. So in the previous class we have seen that there are different type of shift registers and there are different ways in which we can input the data and we can take out the data. So in this diagram you see that we have taken 4 flip-flops. So why I have taken 4 flip-flops? Suppose if I want to enter 4-bit input, so definitely I will take 4 flip-flops. Okay, so I have taken D flip-flop here. This is another important thing. So basically in the flip-flop class we have seen that there are different type of flip-flops and D flip-flop is used specially to store the data. So it is the most simplest type of flip-flop. So we have taken here D flip-flop and each flip-flop is triggered with a clock pulse, and this clock pulse is a negative edge triggered clock pulse. So this is another important thing that you have to see here. So now let us see that how it will function. Now suppose if I take an example that you have to store a 4-bit data, that is 111. You have to store this 4 bits to this register. So how you will do? So this one is your least significant bit, okay, and this one is your most significant bit. So when you will enter this data to this register, so first this one should be entered over here, because when this one will come here, then it will shift here, then it will shift here, then it will shift here, then again it will shift here. So we will get 1 as the output. Then again when this one will come here, so again it will be shifting. So the last digit or the least significant digit we need to enter first. So this is used, this way of entering the data is used when we are shifting the data from left to right, means it is a right shift SISO or serial input serial output. So let us see that how you will enter the data and how the values will change. So now let us see the working of this SISO. So suppose when there is no clock pulse, in the initial condition when there is no clock pulse, so then what will be the output value of each flip-flop? It will be 0. Okay, it will be 0. It will be 0. Okay, so it will be 0. So when I am giving no clock pulse and when there is no input, so what will be my output? It will be 0, and this output is input to this flip-flop, so it will be 0. Again the output will be 0. So you remember in D flip-flop, whatever is the value of input, same is the value of the output. So in the initial condition when I am not giving any input, so what are my outputs of Q3, Q2, Q1 and Q0? It is 0, 0, 0 and 0. Okay. So next when we will give one input to this flip-flop. Okay, so when I will give one input to this flip-flop, so what will be the output of this flip-flop? It will be 1. Okay, now first see that what is the input to each flip-flop. So I am giving one input to this flip-flop, and what was my previous output? It was 0. Okay, and this 0 is the input to this flip-flop, and again what was my output? It was 0. So this 0 is the input to this flip-flop, and again this 0 is the input to this flip-flop. So I have given 1 to the first flip-flop, 0 is going to the next flip-flop, again this 0 is going to the next flip-flop, and this 0 is going to the next flip-flop. So when the clock pulse will be triggered, means when the clock pulse will be from 1 to 0, because it is a negative edge triggered flip-flop. So when it will be going from 1 to 0 means this, then what will happen? My output will be generated. So due to this 1, my output will be 1 over here. Then due to this 0, my output will be 0 over here. Then again due to this 0, my output will be 0 over here. Then again due to this 0, my output will be 0 over here. So in the first case, what is my output of the first flip-flop? It is 1. Then for the second flip-flop, it is 0. Then it is 0 and then it is 0. After that, my next input will be this to this D3. Okay. Then what will be my input to this D2? So this one was the output. So this one will go as the input to this D2. Okay. Then what will be my input to D1? So 0 was the output. So this 0 will come over here. Again this 0 was the output. So it will come over here. So what are my inputs? It is 1, 1, 0, 0. So let us see what will be the output. So whatever is the input, same will be the output. So the output for D3 will be Q3, means it will be 1. So for the next trigger, okay, it will be 1. Again it will be 1. It will be 0. Okay. And it will be 0. Okay. So similarly, when the next one will come over here, so again it will be 1, 1, 1, 0. And similarly, when the last bit will come over here, so similarly the values will be changing. So it will be 1, 1, 1, 1. So this type of table you should get about the output of the serial input, serial output shift register. So now let us draw this clock pulse in the timeline diagram. So let us draw the 3 Q3, Q2, Q1 and Q0 over here. So suppose this is Q3. Okay, this is again Q2. Then this is Q1 and this is Q0. Okay. So this is my clock pulse number 1. This is 2. This is 3. This is 4 and this is 5. Okay. So let us write it 1, 2, 3, 4 and 5. Okay. So in the first clock pulse, what was the value of Q3? It was 0. Okay. Then in the second one, what was the value of, what was the value of Q2? It was also 0. Then this was also 0 and this was also 0. Okay, so all the Q3, Q2, Q1 and Q0 was 0. Okay. So after this, in the next edge triggering, okay, it is negative edge triggering. So this is my negative edge triggering. So up to this it will be 0. Okay. So after this, Q3 is how much? Q3 is 1. So okay, so I will put it like this. It will be 1. Okay. Then what is the value of Q2? It is 0. So it will be same 0. Again Q1 is 0. And Q0 is also 0. So again in the next clock pulse, so Q3 is 1. Okay. Again this Q2 is also 1. So it will be 1. Okay. And Q1 and Q0 will be 0. Okay. Again in the fourth clock pulse, Q3, Q2 and Q1. All these three are 1. Okay. Then this will be also 1 and this will be 1 and this will be 0. Okay. Now in the last, that is in the fifth clock, all are 1. So 1, 1 and 1. Okay. So this is my timeline diagram, and you can also write the values in the first clock pulse. Okay, in the first clock pulse, what was my binary value stored in the register? It was 0, 0, 0, 0. Okay. Again in the second clock pulse, what was my value? See here. From here, what is the value? It is 1, 0, 0, 0. Okay, this is 1, 0, 0, 0. Again in the next clock pulse, it is again 1, 1, 0, 0. So we can write it 1, 1, 0, 0. Again see here it is 1, 1, 1, 0. So it will be 1, 1, 1, 0. And again here it is 1, 1, 1, 1. So it will be 1, 1, 1, 1. So in this way, in the in 5 clock pulses, means basically in the 4 clock pulses, because first one was the initial condition. So in the 4 clock pulses we have stored the 4 bits. Okay, so basically this serial input serial output is used in long distance transmission lines. And there is one problem, there is one drawback of this system, that we need lot of clock pulses to store the data. Up to this much we have only stored the data. After this, if we want to retrieve the data, if we want to take out the data, all the 4 ones, again we need more number of clock pulses. So how this problem is overcome, we will see it in the next class. Thank you for watching the video. If you have any doubts or any suggestion, you can put it in the comment line.